Hello there, this is Gregory Carlson teaching college algebra, and we're about to start section 1.7, but I want to take a brief intermission to talk about a subject that is very important, and that subject is interval notation. And this is something that just tricks a lot of people, but it's actually quite simple, so we're going to take a minute just to look at interval notation. So far, the equations we've been solving have pretty much just had one or maybe two answers. However, in the 1.7, we're going to look at equations that have a lot of answers, even an infinite number of answers. And interval notation is a way to write a set. Interval notation is a way to write a group of numbers in an interval that are all whatever you need them to be. So they're born from inequalities. So first off, let's cover something really important. Consider x is less than or equal to 2. If this is the case, then x is any number that is smaller than 2 or equal to 2. And so 2 is a solution. However, if I have x is strictly less than 2, then 2 is not a solution because 2 is not smaller than 2. So if it's 2 is less than or equal to 2, 2 is a solution. If it's strictly less than, then 2 is not a solution. Same for a greater than sign. If x is bigger than or equal to 10, then 10 is a solution. If x is bigger than 10, then 10 is not a solution because it's strictly greater. All right, so when we're doing this, here's the idea. When you see an equal sign, you should think bracket. When you don't have an equal sign, you should think parentheses. So for example, if x is between 3 and 5, so x is any number that's bigger than 3 and smaller than 5, then the way you would write that is this right here, bracket 3 comma 5 bracket. And I know that's a little hard to see, so you'll want to have this page printed out. So what would that look like on the number line? If you draw a little number line, 0, 1, 2, 3, 4, 5, 6. On a number line, if x is between 3 and 5, these would be solid dots because x can be 3 and x can be 5. So you would shade it like this. So x can be any number in between these 2 points, including these 2 points, which make them brackets. And one way I remember this is you see how there's kind of an equal sign on the bracket because the top and the bottom are flat? That's how you know that a bracket means equal sign, because there's a little equal sign on the bracket. Check out this next one. X is between 2 and 4. There's no equal signs here, so you would write that as parenthesis 2 comma 4 parenthesis. This right here means the same thing as this right here. This is not a coordinate. I know it looks like a point. This is a range of values that x can be. So if you were drawing this second one on the number line, it would be, I don't know, let's just put 0 here. It's every number between 2 and 4, but not including 2 or 4. So you'd actually put little empty holes or empty circles on 2 and 4 and shade everything between them. So in this case, x can't be 2 and it can't be 4, but it can be every number between them, even going all the way up to 2, infinitely close, but not actually touching 2. All right? I shouldn't say infinitely close. I should say closer and closer. Anyway, so see the difference between bracket 3 to 5 and parenthesis 2 to 4. Now, this next line, I have one missing equal sign here and an equal sign right here. So I would do parenthesis 2 comma 4 bracket. And I know that looks terrible, especially if you're a programmer, but that's really important. If you were programming, this would probably fail if you had a parenthesis being closed by a bracket. That's why I mentioned that. But in this case, it makes sense because we're not including 2, but we are including 4. So on the third one on a number line would look like this. We're going from 2 to 4, so let's just put 0 there. All right, so we're not including 2, so I put a circle there. We are including 4, so let's put a solid dot right there because we are including it. And we just shade it in like that. So that's how I like to do them. Sometimes you'll see people actually put the bracket here instead of the solid dot and the parenthesis here instead of the open dot, but they mean the same thing, so I wouldn't worry too much about it. And this last one, we are -6 inclusive, but not including 10. So it's a bracket around -6 going up to 10. So let's see what that would look like on a number line. Here's 0. We'll just put -6, I don't know, around here maybe, -6. I'm going to count by 2's. That's not exactly spaced evenly, but oh well. So we're going from -6 to 10. We are including -6. We're not including 10. And we're going to include everything in between. So that's what those 4 look like on number lines. 2 things to know about this. First of all, notice that the left number is always smaller than the right number. That will always be the case because, again, these are just like number lines, and we're always going to go between 3 and 5. The only tricky part is brackets or parentheses, whether or not we include the endpoints of the interval. So the left number will always be smaller than the right number, and you can see why when you see the number lines. Now, the way this is going to work is, in the future, we're going to solve an equation that has a lot of answers, and you're going to get something like this. You're going to get 3 x's between these two numbers, or x's between these two numbers, and it equals that, but not that. And so you need to be able to translate each of these into their interval form notations. This is what the final answer should look like. You're going to use this again in calculus, so we might as well learn it now so that we don't have to relearn it when we get to calculus. So that's basically the idea. Now let's take a second to talk about infinity. Like for example, we had x is smaller than 2. That means that x can be any number smaller than 2, getting more and more and more negative as far as you want to go. So how would we represent that? Well, essentially, you never ever ever put brackets around -infinity or infinity, okay? Because you can't reach infinity. Infinity is not even really a number, it's more of an idea. So in fact, this right here, from -infinity to infinity, this is a fancy way of saying all real numbers, or all solutions. Okay, -infinity to infinity is the entire number line because it's going all the way down to -infinity and all the way up to +infinity. So remember, anytime we have an answer where we get an answer and the answer is all real numbers, the way you write that in interval notation is -infinity to infinity, always with parentheses around them. So it's kind of the opposite idea of the empty set. The empty set is nothing, a 0 with a line through it, no answers. Here is all real numbers, -infinity to infinity. So just as a reminder, the empty set, which is empty brackets or the 0 with the circle through it, that's how you would say no solution. So in interval notation part 2, we'll look at a few examples of what things look like with infinity in the interval notation. See you there.